Hello, welcome to the Thermodynamics Part 1 podcast. Thermodynamics is different than thermochemistry because this is going to involve calculations with delta G. But in this part, I'm going to review all of the delta H, which is really just thermochem. So, if we remember from our past podcasts or from class, delta H is called enthalpy and it's the heat transfer energy. And so, there are basically two types of delta H. And remember, you can calculate delta H lots of different ways. You can do it by bond energy. You can do it by calculating Q. You can use it by using heat of fusion, heat of vaporization. You can use enthalpies of formation. You also can use energy graphs. So if we have a reaction and it's endothermic, it means it's absorbing heat energy. So your products are going to be higher up than your reactants. So it's going to give you a positive delta H. It's gained in heat energy. For a exothermic reaction, it will have given off or produced heat energy. So your delta H is going to be negative because you're releasing heat energy. All right, so determining the sign. So when we do thermochemistry, we're actually going to want a number always for the delta H. You're going to have to calculate how much energy is released. You're going to have to calculate a change in temperature. You're going to have to do some sort of calculations. A lot of time in thermodynamics, we just want to figure out whether delta H is positive or negative. So let's say that we mix two chemicals together. So we've got chemical 1, we've got chemical 2. They mix, and the reaction gets hot. Okay, so if the reaction gets hot, that would be a negative delta H, okay? So plus in temperature, right? So that can be kind of confusing because the temperature is increasing. So you think it's actually absorbing heat energy. But remember, with all of thermodynamics, with all of thermochemistry, it's always a system of changes because it's not ever H, it's always delta H. So one thing is giving off the heat energy, something else is absorbing it. So the reaction is giving off heat energy and the water is what's absorbing it, or the air or whatever else is around it. So it's sort of a pair. The water is endothermic, but the reaction itself is giving off heat energy, so it's exothermic. You cannot use this with all processes, but for two reactions that are starting at room temperature, this will work. If you also, let's say we do the opposite. We add these two together and it starts to feel cold. That's a positive delta H because it is absorbing heat energy. And the reason why the reaction will feel cold is because it's removing the heat energy away from your hands. That's why you get the cold feeling. All right. So determining delta H for things like phase changes, you can't think about it in the same terms as you would a reaction because a lot of these cases you're putting heat energy into the reaction, and so it's not just two chemicals are at room temperature and then you have a temperature change. You're actively changing the temperature. So let's take a look at two examples. In the first one, we're starting with liquid water and we're turning it into a gas. So in order to do this, you're going to have to add heat energy in. So you're going to add it as a reactant. Because in order to get water to boil, think about it. You put it on a stovetop, you turn on the stove, you're adding the heat energy into it. When delta is on the left side of a reaction, it is endothermic, okay? So you're putting heat energy into the reaction. Okay, so now if we look down here and we do the opposite, if it's a gas and it's going towards a liquid, okay, that is releasing heat energy. So this would be exothermic. It's expelling heat energy. And this also makes sense because when you break bonds or intermolecular forces, so in this case going from a liquid to a gas, you're breaking the intramolecular forces, namely hydrogen bonding, right? And so it takes energy. That's why it's endothermic. When you form a bond, like when you form liquid water, you're forming the hydrogen bonding, the intermolecular force. So once you form that bond, it releases heat energy. Okay. In the next podcast, I'm going to explain delta H. Delta S, entropy, and I'm also entropy, and I'm also going to be explaining Gibbs in other podcasts. So each one's going to be kind of short.